Hello and welcome to the third tutorial on MIPS programming using Mars. In this tutorial, we'll see how to write MIPS instructions to transfer data from memory location to register, and at the same time we'll see how to handle data of different types such as integers, character and string. So let's begin by first looking at how to write a program where the intention is to transfer data from a memory location to a register. So as in the case of any program, we should first define the two segments, dot data and dot text. Dot data to keep the data which will be used. In this case, we need that, and dot text which contains the instructions that will be executed. Okay, so the first thing to do is let's first initialize a register called, let's say, AT, and initialize that with the location where we will be storing our data. So we assume that our data is in location 0x10010000. So that's a 32-bit register, which one is one of the locations, or a 32-bit address, which is one of the locations in the data segment of the memory, and we assume that our data is in this particular location. So we initialize the data, or initialize the register $8.80 with the address, so that 80 now acts as a pointer pointing to the particular address location. Okay, so next thing to do is we'll try to load the content of okay, so we'll try to load the content of this address to some register. Let's call it WT1 $T1, and okay, so the location pointed to by this particular register called 80, so which in this case is this, should be loaded to, so load the contents of the location pointed to by $80 to $T1. So that's the idea. I hope that should work. Okay, so we haven't mentioned what is stored in this location. So what is the data? So that should be defined in this. So let us assume that, okay, so here is 10010000. So this is the data that we would like to this is the location where the data should be stored, and let's define the data to be of type byte, and say we have something called 5. Okay, so this should be okay, and let's try to run that. Well, we get an error. So, and the error says that this definition is invalid, so this does not work out. So what to do? Okay, so what we'll do is, instead of mentioning specifically a memory location, let's try to rewrite this by defining something called a placeholder. Okay, placeholder means some kind of a variable, and let's say the variable is actually a reference to that particular location. So in this case, let's say we define something called int, and int is a variable that corresponds to a particular memory location. Let's assume that okay, so what is this int? Int is I can say uh, a symbol uh, symbol to refer to a memory location. So what do we infer from here is that int actually is a placeholder, or you can say a symbol which represents a memory location. Okay, so instead of specifically mentioning the address, you mention it in the form of a string called int. So we call this thing as, and is known as label. So we'll call these kind of representation of memory locations as labels. Fine, so that's what we do. Now what to do here? Well, the problem is that now we cannot define, or we cannot load 80 with the address, but rather we will be loading this with int. Okay, but since int is not a, a binary pattern, so yeah, it actually represents an address, so we should mention that 80 is actually loaded with a memory address, and this is how you do it. So the instruction to do is okay, it actually means that $80 is loaded with an address which is referenced by the label int. So that's what it means. Okay, so LA stands for load address, and it actually loads the $80 with the address which is referenced by int. Fine. Now what to do? Now we are in a position to run this. I hope it works. So let's first save this and let's run. Well, so that works. So let's have a look at what is there in the text segment. Well, we just have two instructions in the text segment. One is load address, that again is a pseudo instruction, as you can see here, because that eventually is broken down into two basic instructions of MIPS. So the idea is that whatever you have mentioned as an address through the label int is actually loaded into AT. So let's have a look at AT, keep a track of that, and let's see what gets loaded after this instruction is executed. Okay, so after this instruction is executed, we have AT loaded with the address that we expect to be stored. And what is it? It's int. By the way, what is int? Int is the value, int is the label to a particular memory address. What is that? Well, remember, go back. So int actually is a location in the data segment, and it contains a byte whose decimal value is 5. So what is the location to which it has mapped to? Well, it has mapped to here, we see. So this is the location 10010000 that actually contains this integer. So int has been mapped to an address 10010000, and it's already containing the data. Well, so the interesting point would be that how this data, which is present in this location, will be transferred to $T1. Okay, so let's go to the next instruction, and on executing that, please keep a watch on $T1. Let's see. Well, so this is highlighted by this line where you see that on executing the last instruction, which is LW, stands for load word, the word pointed to by the $80 register will be transferred to $T1, and that's what it reflects, because $80 contains the address pointed referenced by int, which is actually this address, and the address mentioned here, it contains this value, and that is what is transferred to T1. So this is the way that we will actually be transferring data from memory to a register. So you need to define the data in the data segment of the program by using a label and mentioning what kind of a data followed by the value, and then apply that in the text segment where instead of mentioning the actual address, you mention the label to reference to a particular memory location. Okay, so that's it. But the problem is that we are not able to obtain the value on the screen or on the terminal. So let's utilize the system call to print this on the screen as well. So what we will do is we will try to first define the system code, and to do that we will make use of the $V0 register and load it with the system code. So this is the one that we know, the system code to print an integer. So that's what we have come across so far. and then we'll try to define the argument. And where should the argument be defined? In a register called A0. What will be the argument? Well, the one that you would like to print, and nothing but the content of T1. So what we'll do is we'll move the content of T1 to A0. So that's actually copy the content of $T1 to $A0. So after this, what we have is $A0 also contains 5, pretty similar to $A1. Okay, and then you request the operating system to print this. So let's first save that and let's execute. Okay, well, so there you see the output gets printed. So this is how we will be able to fetch some data from the memory. So henceforth we will not be referring to the memory locations or the registers to view the outputs. Rather, we'll be making use of the syscall and the $V0 and $A0 registers to utilize the operating system to print the output. Okay, so let's now move towards the next program where we would try to see how we can print a character. Also, this is what we have done. So the easiest way to do is this. Okay, so we have the .data and the .text section, and what we do is we initialize a memory location, give a label for that named character, and it is of type byte, and this is initialized with the character A. So in the text segment we would like to print a character. So the system code in this case is the system code for printing the character. Okay, 4 is the system code for printing the character, which we load onto $V0, and then we pass the argument to $A0, which is the reference to the memory location that contains the character A. Okay, and then we ask the operating system to perform the task of printing by giving the command called syscall. Okay, so let's save this and let's run it. Okay, so it's executed, and there you see. So let's run it again. Okay, so here you go. So it's a simple program where we just defined the data, which is a character called A, and we did that by mentioning the location through a label character, and we defined the type of data, and then we gave the system code. We loaded the $V0 with the system code, and we loaded A0 with the argument, which is nothing but the label character. Okay, so that's about how to handle characters. Let's now move towards another program where we have defined as something like we've already seen that, so it's needless to say. Let's move to a program such as, let's say, where we would like to print the a string maybe. So here's a program that is expected to print a string. So it's pretty similar to what we have just seen of printing characters. So it's again consists of, so here we have a program MIPS code to print the hello world. Okay, print a string, so in this case hello world. Okay, so as in case of any other program, we first define the data in the text section, and then we initialize one of the locations in the memory by the string called hello world, and we reference that by a label called str. So str refers to memory location in the data segment that contains the string hello world followed by a new line character. Okay, so this is the string that we would like to print, and what str does is str is a label that refers to this. So in the text segment, the first thing we need to do is, okay, so here is the system code to print a string is 4. Okay, so that's what you do, and then you pass the argument in the $A0 register, okay, by mentioning the string. So what happens after this instruction is $A0 is loaded with the memory location referenced by str. Okay, so let's save this and let's run it. Okay, so it says operation completed successfully. Let's go one by one. So the first thing that we expect is the V0 to be loaded with 4. Let's keep a check on the V0 register here, $V0. This is the one, just keep a check on that. Let's run this. Well, so that's what is shown here. So we load V0 with a constant 4, which is the system code for printing a string. Let's now see the result of execution of the second instruction, which is loading $A0 with the memory location pointed to or referenced by str. Okay, so have a look at str, which is 1001 followed by 4 zeros. That's the same thing as this address, which is the address at the one of the locations in the data segment, and this is the content. So A0 now is loaded with the location referenced by str. Okay, let's move to the next one, and let's now see the execution of this is code. Okay, here you go. So the hello world is printed at the bottom. So a quick summary, what we did is we defined the string that we would like to print. We initialized a particular memory location in the data segment by the string, in this case the hello world followed by new line character, and that location is actually referenced by a label called str, and the type that is associated with the string is called ASCII Z. Okay, so in the text segments is the same approach. We first load the $V0 register with the system code, then we pass the argument to the str, which is nothing but the reference to the memory location which holds the data, and then we ask the operating system to execute that through the command system call. Okay, so that's about it in tutorial 3. In the next tutorial we'll see how we can handle floating point operations and a few arithmetic operations.